Hi, my name is Eli Gregory. I am a software engineer with the Runtime team, and I'm here today to talk to you about how you can jumpstart your app development with open source apps available on GitHub.
All right, off the top, what are open source apps? The ArcGIS Runtime open source apps team is a team dedicated to building open source tooling and applications designed to help you get work done. We adopt a narrative-forward, workflow-focused approach, identifying common workflows through engaging with customers and building apps that solve for these workflows using ArcGIS Runtime and doing so totally in open source. These apps are fully finished, meaning they solve a complete workflow and are feature complete. And because these apps are an open source, you are invited to augment these apps to suit the custom needs of your organization. These apps adopt what we call ArcGIS best practices, a set of techniques for consuming runtime APIs, as well as implementations following popular and standard platform design patterns. Most importantly, licensed under the Apache 2 license, these apps are written for you, are available right now, and are completely free. All right, let's have a look at some of the open source apps workflows. First up is data collection. Data collection is an application built using the Runtime SDKs for Android, iOS, and .NET, adopting a design for desktop in .NET and for mobile in Android and iOS. The application is designed to be an online to offline workflow where you begin by configuring a web map, and using the on-demand offline workflow, you can take an area of the online map offline. The application also demonstrates how to grant logins to authorized users. It allows you to interrogate your map, finding and displaying your features as pop-ups with additional UIs that allow you to edit those pop-ups. Those UIs are enhanced even further by revealing related records, allowing you to edit those related records as well. And those UIs additionally allow you to view and add media attachments. The application also demonstrates a workflow using a locator task to reverse geocode for an address.
Next up is Dynamic Situational Awareness, also known as DSA. DSA is built using the Runtime SDK for Qt and targets multiple platforms. DSA Vehicle runs on a laptop or tablet and is targeted for vehicle use. DSA Handheld runs on a phone or small tablet and supports on-foot handheld use. DSA is designed for use in disconnected, intermittent, and low bandwidth environments and includes tools for sharing situational awareness information, collaborating with teammates, and performing visual analysis. The high-performance app is built in 3D, works purely with local data, and utilizes peer-to-peer messaging. The app allows your users to share valuable information with their teammates on a 3D map over a secure peer-to-peer tactical network. The app is designed to be used in the field by users who need to securely collaborate with their teammates. Users can share markup such as text and sketches to convey information about situations, problems, and solutions. The application can be configured to trigger alerts for when real-time data feeds and messages meet specific conditions, such as a geofence intrusion. The application can leverage a viewshed to instantly analyze what features are visible in a 3D map from various movable locations. They can also use the line of sight to determine visibility between a moving observer and one or more moving targets. The app dynamically displays military symbols based on the symbol ID code contained in a received location updates. And lastly, the application supports converting location coordinates between various common coordinate notations. Next up is the Maps app. The Maps app is built for Runtime SDK's iOS, Android, and .NET, and is designed to be a mobile mapping solution that is already familiar to your users. The app provides a user experience popular in consumer mapping applications and includes common capabilities such as search and routing, as well as some unique to ArcGIS. The application comes with custom UIs to search for places and see suggestions using the ArcGIS World Geocoding service. You can also type a search query to see a refreshed list of suggested results nearby to their location. The application enables your users to find the most appropriate address for any point on the map. They can select and hold a point on the map to reverse geocode into an address using the ArcGIS World Geocoding service. The application supports generating a route and getting directions. Tapping a button generates routes between a predefined origin and destination. The application supports switching base maps and comes with a default gallery that allows changing the map's current base map by selecting from a variety of standard Esri base maps. Offline Mapbook is an open source app built using the Android, iOS, and .NET Runtime SDKs. And it's an application that gives users the ability to load mobile map packages to a tablet and to access these maps while they are in the field when they don't have internet connection. With Offline Mapbook, your users can create mobile map packages using ArcGIS Pro, and then download or sideload them to a tablet whenever they anticipate future work in a place that's disconnected. The application comes with custom UIs that allow your users to browse for items in their portal. You can configure the application with a portal URL and browse for mobile map packages matching a portal search query of their choosing. The application also comes with custom search UIs, allowing your users to access and search the contents of locators that are packaged with the mobile map package. When viewing their maps, users can search against their packaged locators by typing a query in the search field to see matching suggestions. Selecting a result from the list will locate it on the map. The app supports tapping the map to display its contents. Users can select a feature on the map to view the details of that feature. Feature attribute information is displayed in a callout that moves with the feature as the map's viewpoint changes. And last but not least, we have Nearby Places. This open source application is built using the Android Runtime SDK, and it's designed to help your users discover what's in the world around them. The app recommends and displays places of interest contextualized by the user's location. Upon choosing a place, your user can request a route and get to where they want to go. The application comes with customized filtering mechanism that allows your users to refine what kind of places are returned as results. If the user changes location, they can refresh the results with places near to their new location. After deciding on a suggestion, your users can generate a route to a place nearby using the routing service and display the route on a map. Next up, I'd like to demonstrate data collection. This version of data collection is built for .NET WPF. Before building the application, you configure the application with a portal base URI and a web map item ID. I've done that, and the application is launched. Upon launch, the web map is displayed in full screen with some UI elements overlaid on top. There are a number of ways of interacting with your web map. You can pan, pinch, and zoom. You can click zoom out, click zoom in. You can go to the default extent and you can zoom in on your own location. There are a number of ways of interrogating the contents of the map. You can show the legend. This will show the symbols for all visible layers. You can show the table of contents, which will allow you to toggle the visibility for layers. You can learn a bit about the metadata of the application there by tapping the About Info pane. Toggling the user pane, you can sign in and sign out of the configured portal. And tapping the working pane, you can toggle between working online and working offline. Before this video recording, I have taken an area of this web map offline using the on-demand workflow, and I'd like to demonstrate the process for adding a new feature in the offline map. I'll jump to the offline map and I will select Add Feature. I will click and pan the map underneath the feature and select this location in the park. A new feature is created, and it was planted by Jack today. Next up, the application supports related records, and I'd like to add an inspection record, which is a one-to-many inspection relationship. So I inspected this tree on today's date. The condition is good. As you can see, the map updated the condition of the tree and the symbol as such. I'll close that feature. And now that I'm finished with work for the day, I will synchronize the offline map with the online map once I get back to the office. This particular demonstration is built for the iOS build running on iPad, an iPad simulator. When the application launches, the UI presents a map full screen. There's a search bar across the top and clustered buttons in the bottom right. A portal browser allows me to sign in and sign out of my portal and access my web maps. A base map picker allows me to change the underlying base map of my map. Let's change it to the navigation base map. I can zoom to my device's location. It'll take us straight to Palm Springs. I wish we were at the Palm Springs Convention Center. And I'd like to go back to my hotel. I'll tap the search bar, type the address, select the suggestion, and get some directions. It's not very hard, only a few steps. I can enumerate through the various steps. And I've arrived at my destination. This demonstration builds the Android app and runs the application using a Pixel C emulator. Before building the application, you configure it with a portal-based URI and an item ID to the mobile map package. The application will launch. It will request user credentials, and upon authentication, download the mobile map package item. Once the download's complete, it loads the mobile map package and presents it in this here UI. I've already downloaded the mobile map package for the sake of brevity. The mobile map package contents are displayed here, metadata up top, and a list of the contained maps on the bottom. Selecting one of the contained maps will load that map in a map viewer, and the user has a variety of means of interacting with that map. They can toggle the table of contents and legend. In here, you can toggle the visibility of certain layers. They can toggle the bookmarks, allowing them to zoom to various areas of interest in the map. And if the mobile map package contains a locator, the application contains a custom UI that allows them to search the locator, providing suggestions along the way. You might be wondering next, where can I find these apps? How can I get involved? These applications are all contained by GitHub, so feel free to fork them and configure them with your data and build them. If you have any feature requests or you've identified a bug, you can file an issue and we will attend to that issue. If you want to offer an enhancement, you can submit a pull request. I promise if you talk, we'll listen. You can access a comprehensive list of all the open source apps online at the developer site. Thank you so much. We're looking forward to hearing from you, and we're looking forward to seeing what cool things that you can build with open source apps.